Greetings everyone, welcome back to the channel. I recently got a comment on one of my videos suggesting that I should do some curvilinear motion logic kind of thing for an AC-130 cell gunship. Which sounds interesting, so let's try it. So this is another logic-based video where the plan is, I have this gunship without any weapons as of right now because I just built it. It was just quick build. And yeah, I want to make it so that I can set a specific radius to circle around, and it will automatically loop around the radius. Just like, it'll turn by itself. I won't have to do anything. So then I can just man the cannons. That's the plan. And I did do a bit of thinking about this. I do know what logic I need, most likely. So, yeah, I'm excited to try it out. But before we start the logic, I think this needs some cannons. So let's add a few cannons. Okay, I've added a few weapons, just a minigun and a cannon, nothing much. If I press 2 I can activate the cannon aiming. If I press 1 I can activate the minigun aiming, which you only have up and down because it doesn't really matter that much. And with that, we have weapons now. Let's do the logic. Okay, so let me run you through what the entire plan here is. So as our plane's flying, also yes, I switched out the rockets because, well, too much fire. So as our plane's flying, which is currently not flying very well because of those cannons, I would set up a radius. And the way I'm going to do this is I can use the formula of angular velocity, which is usually represented by lowercase omega, is equal to v, which is my forward velocity, or tangential velocity in the direction I'm going basically, over my radius of curvature, which is the radius I set it to. So I can do a bit of simple math, just dividing my forward speed by the radius to get what angular velocity I'm getting, or what I want at least. And then I can measure angular velocity. Now this one's a bit more complicated part. I have to measure it using a compass block. That's my plan. You can also potentially measure like normal velocity by putting a sideways facing speed sensor and do it that way, but it's simpler just to do this. So you have to measure angular velocity with the compass block, but the compass block, guess what it doesn't do? Measure velocity. It only measures what angle you're facing. So for this one, I'm actually going to have to find the derivative of the compass block, like the angle I'm facing, and that might sound complicated, and it is, but I have an idea for that. So for that one, what I'm going to do is, we have the compass block, we're measuring some value. I then want to save that value that it measures at like each clock pulse basically. First tick, I measure what my angle is. Second tick, I take what my angle measures last tick and subtract that from what my angle is this tick. And I have to keep on doing that. Basically, I have to save the previous angle in like a simple memory kind of thing, so I can recall it later. And then I just gotta compare that with the velocity I want to be, and then adjust the plane accordingly. Not nearly as complicated as our cannon aiming logic from last video, or a few videos ago, but still quite interesting and a lot more mechanical this time, so I'm actually not sure if this will work. That was more just creating an equation. This one's actually incorporates mechanical aspects. So this actually might be more difficult, but let's try it. Okay, firstly, let's just do the simple part of we can set an angular velocity and then the plane just copies that. So the way I'm going to do this is I'm just going to pick some block like here, put an accumulator, and let's send that to a number display. And this is going to be our radius. We can just keep it as meters, I guess. From 0 to 100 meters. 100 meters doesn't seem that long. Okay, maybe not this is our radius, this is our tenth of a radius. So that's 100, so we're just gonna have to multiply that by 10. Where are you? There you go. You go into there. Okay, and you can multiply by 10. So now, each one of these is 10 meters. It's 1 decameter. Now, a scale of 1 is way too slow, because that's gonna take 100 seconds for us to get to 100 meters. So maybe a scale of like 50, so it takes like 2 seconds to get to our max distance, and then we can adjust the distance accordingly. Okay? There. That's pretty good. It's a bit fast. With this value, this is our number value, now we want to divide that by our forward velocity. We can probably set up an accumulator or something to accumulate up speed and then accordingly vector like adjust thrust. Yeah, let's do that. Accumulator, perfect. Set it up as base, or no, shift and control. This is our throttle up and throttle down. That's you have to be facing forward. This is gonna go between. What speed should we have it? How fast does this plane go? I should probably check that first. It goes about 250. Sure, we can create that. 250. So for this, we're gonna have set to from 0 to like, I don't know, 25. We can also multiply that one by 10. So you go to there. You are going to multiply by 10, perfect. And we can also display that. It's gonna be our speed value. And a scale of 20 is way too much. Great, okay, this is our speed value. So what do we want the speed to? Now, we can compare that to what our actual speed is and accordingly adjust thrust. Where are you? Speed sensor. This one has to be facing forward. Speed sensor measures the speed. And you can just set to measurement. Measurement. And you're in meters per second, you're in meters per second. No, you're in kilometers per hour. I'm actually going to multiply by 10 over 3.6. And for the purpose of displaying what speed I'm going, I'm going to actually keep this 10. I'll divide by 3.6 later. After this. So, make another one of these. You go into there. Just so that this can still display what the number is, the speed. Okay, so now you and you are both measuring the same units. You have to be divided by 10.6. You're going to be 1 over 3.6, which is 5 over 18, which is 0.2777777777778. Sure. We're not doing this. You are actually going to be the number 3.6. You're gonna get divided by -1. And multiply, yeah, no, the power of -1. X to the power of constant of -1. Not -11, -1. Great. This is so overcomplicated for no reason. Now we have the proper value we want. Great, that'll work. Now we gotta compare it with that number. We're spending way too long on this. You go to there, you go to there. Now whatever number we have, it's gonna be negative, so it's gonna be that minus that. So if this number is bigger than this number, then we have to turn off the engines. If this number is smaller than that number, then we have to turn on the engines. So now it's as simple as we put one of these. If this is less than 1 or less than 0. If this is less than 0, then you can output 1 to all the engines. It's working. If I set a speed of... Okay, that's me. Okay, that works, that works. Just plane can't fly at slow speeds. And now we're a boat. It works! Okay, I might have to replace the wings with spoilers. This does not have enough lift. But, okay, this works. Perfect. Now we need to make sure it stays at 1 altitude. We need an altitude hold logic. So, great job. You all work just fine. I'm gonna move you to the front. All the way up here. I'll put you properly somewhere later. Okay. I just forgot you. Get over there. Okay, great. And now we need altitude hold. What is wrong with you? You know what? We're gonna pretend we're not a plane. What do I mean by this? Can we pretend this is not? We haven't even started the main logic yet, and I'm already confused and annoyed at the game. This is not going well at all. You press button and plane becomes not plane. It flies like an airship. You press button, the plane becomes an airship. And it's fine. I don't mind. Great. Now that we're done with that, and we're just gonna pretend that works good enough, let's get to the actual logic! Yay! Okay. So, since we're now an airship, I guess I don't need to do the whole roll and then turn, I can just turn with the yaw directly. I'll probably make this work better with as a plane in sometime in the future, but I don't want to bother with that. That's gonna take way too long right now. So okay, this is gonna be our roll gyro. Or yaw gyro, sorry, my bad. And then we put another one of those, so now we have 2 yaw gyros. And now, it's fun logic time. Firstly, we need to do the whole logic with the radius of curvature. This is going to be our radius value. Now we want our angular velocity instead. So you are actually going to go into another block. And this is going to be power to x to the constant. Yeah, that one. -1. Perfect. Great. So this is -1. This is going to be 1 over whatever angular velocity we have. Perfect. And now our speed is over here. Which speed are we taking? Could really be any of these speeds. Can even set that. That's actually probably the best one, because this is our actual speed, no matter any fluctuations. Perfect. Not into there. So okay, we're just gonna use the speed sensor. It's simpler and less fluctuations and more accurate. Okay. Why did I put that block? I meant an aggregate. So now I have to multiply V over R. Yes, great. You can actually go into the negatives, so we can have the left side and the right side. See, I'm being smart. We can have a negative and a positive radius. Now, we need to do the difficult part. This one, we're actually going to need to do the roll stabilization thing that we did earlier, because we, as you know, it's plane stabilized. I forgot the plane stabilized. It's fine, we don't need to do that. You're going to be width all the way. You're going to trigger as measurement. Perfect. Now, we want some sort of memory circuit. And I have an idea. I highly doubt this will work, but if it does work, this is going to be insane. It's going to be the best memory circuit you've ever seen because of how simple it is, if it does work. If it doesn't work, then we're going to have to do something more complicated. So we take the value over here, that's good. We want an instant value, we want a delayed value. Now, logic gates have a slight time delay between signal sending. I don't know how much, we're going to have to measure that. Accumulator. There. Accumulator. Number display. Accumulator will have a NOR gate. NOR. Perfect. This is just me measuring how much time delay each logic gate has. Except we can put like 10 of them so that we're more accurate. A NOR gate is going to send the input into that. It's an input into. That's one. One jump. 2 jumps. 3, 4, 5, 6, 7, 8, 9. And 10th jump is into there. Into the accumulator. Like, great. You go to there. 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 You go to accumulator. Perfect. Yeah, it should just straight up work. And our answer is 0. Our answer is 0. Presume it's pretty fast. Okay, that's really fast. I think we might need a few more logic gates. You know what I just realized? I could just set a delay on one of these, and then just know the time interval directly, instead of doing all of this. I could just set a delay. It would have worked just fine. In fact, I could still do that. And now I'm too committed to this bit to stop now, even though I could straight up just set a delay, because there's a delay option right there. Let me just try this. First, does it give us a number? No, it doesn't. You know what? We're not doing this. We are not doing this. Out of here. We've wasted enough time already. Get back here. We are not doing this. We're just gonna put one gate. It's gonna have a delay of 0.01. Very tiny, I know, but the less the better. Now, both of these go into a gate. You're gonna not be one of those. You're actually gonna be one of these. You're gonna have a delay of 0.01. Does that work? Does that even work? I don't think that works. Eh, whatever, let's try it. Multiply by -1. So this should be minus summation. And now as we turn, it should give us a number. Not giving us a number. Okay, it's outputting some numbers, just number display is not showing it. You can tell it's outputting some number because summation gate's showing it output. Did I plug in the number display? Would you look at that? Okay. For real this time. I think it's outputting our angular velocity. We're faster, now we're slowing down again. I think it's working. You know the random flickers? That's whenever it switches back from -180 to +180, like that, or the other way around. Do we need this many? I don't think we do. So my system actually works. I can use this as memory. I mean, it's giving me a number. I just don't know what the time frame is. That might be a problem. I might need to know what the time frame is. Wait a second. Back when I was doing the whole accumulator thing, was I just not connected? No, there's no way, right? Accumulator. There's no way I just didn't connect it, right? There's no way, right? I think this is exactly what I did. No, no. I didn't do that. Of course I didn't do that. Why would I do that? I'm pro logic maker. I'm so good at making logic. Why would I make a mistake like that? Did I really do that? Did I really make that mistake? I didn't plug in the number display. 10 of these equals 0.15. I actually just not plug in the number display. 0.15 divided by 10 is 0.015 for each logic gate. So I know what the time interval is. Alright, this is degrees, it's not radians. Oh, my bad. It's in degree, it's not radians, of course. Okay, so I am dividing by 0.015. Okay, great. This, multiply, product, perfect. And on this side, we're going to have, do I have an OR gate already? I do. I didn't mean to delete both of them. NOR gate, you are very special. You can stay there and you get to be glowing. Because I'm gonna need you a bunch. Great. NOR gate, you get sent into these. You are multiplied by 0.015. What? Are you really just gonna be like multiplied by 0? Okay, it's probably saved the value. I hope it saved the value. You're gonna be power to the constant of -1. And then you're gonna get sent into aggregate, and so are you. And this aggregate block is gonna give us our difference. No, it's not. It's gonna give us our angle. Okay, no, you're literally just multiplying by 0. Amazing. You are useless. Okay. Maybe I can't store 0.015. I can multiply this answer by 10 and divide by I could do that. Multiply by 10 and divide by 0.15. I don't trust that you're saving the value now. What do I do? Multiply by 100, divide by 1.5. Sure, we can do that. You can save by 1.5, and they're also going to multiply this by 100. Okay? This is going to be perfect. You go into there. You're gonna be multiplied by 100. And then you go into there. Perfect. Multiply by 100. Divide by 0.0. No, divide by 1.5, I guess. I broke something. You don't want that in there. Or you want that in there. Now, you go into there. Product. Wait, you're the product of that. You go into there. That should be our desired value. Did I plug? I plugged it in, right? And we also got the speed. Our speed's 0. That's why it's not working. Okay, why are you 0? Are you radians? Are you in radians? You're in radians. Of course you are. I have to multiply by pi over 180. Or 180 over pi, sorry. We're almost done. Theoretically. Probably not. You're in radians, so now I need to multiply this by 180 over pi. Great, probably just multiply everything together. Yeah. So we need a number for 180 over pi. What is that equal to? There's no pi number in Trailmakers. 180 divided by pi. That is equal to 57.2957791. Now, how do we store this number? Multiply by 10. And then we divide by 10. Yeah. 573.0. Perfect. Now you get sent into there. We also need one more of you. Which actually gets sent into one more of you. I know I'm overcomplicating the logic right now. It's just I couldn't care less. So, too bad. You are going to be 1, 10, 10, 10. Get sent into here. Sent into there. Perfect. Now you should be degrees. That's a very high turn rate. I don't think that number is very correct. It is 33 meters, so that actually does check out. That might be a bit much. 120 meters. That's still a very high turn rate for a 120 meter radius. Is that correct? Going at this speed. And we are going pretty fast as well. Okay, well you're working. Now, it's gyro time. So basically the way this is going to work now is we have our desired turn rate and our actual turn rate. Now, we just have to... Wait. Yeah, get past 93 minutes here, yeah. Now, we just have to take these two values, this and this, and we're going to subtract the two. And then our difference is going to tell us our gyro to turn which way. So if this number, I don't know, I'm just going to plug it in the gyro and then just hope that whatever happens. Let's see if this works. Do I trust it will work? No. But it would be funny if it did. Now, set a turn radius. The turn radius might be too small. Is it working? Is this actually working? Except for the fact that we're going down, but... Is this really working? Oh, we're a boat now. We're submarine now. Let me fix that. Did that actually work first try? I don't know if I can count as first try. It's been like an hour and a half already. But still. Did that actually work? YouTube. You should be 0. We don't want you going down at all. Okay, let's set a speed of... How about 185 kilometers per hour? Perfect. Stabilize yourself. Perfect. Now, Let's turn left. Okay, let's probably just turn left first. Never mind, I have no control over gyros because it's overriding my controls. Great. Let's turn left. And it's working. I set up a radius, and it's turning according to the radius. It's actually working. Like, look at that. There's the measured radius over there, and my actual radius over there. Not radius, my radius is 113 meters. But there's a measured thing over there, and the actual thing right there. And it's actually turning properly with it. Now I can activate 2. I can fire all I want. I can't even shoot my engine off. And it works. Except I can't see where I'm aiming, but that's fine. If I wanted, I can turn the other way. I might have blown off the entire wing, or the fuselage. Now I'm gonna smooth out the logic and like put it inside the plane basically, and let's paint up the plane a tiny bit. And with that, I think we should actually be good with the plane. This actually works. I mean, okay, it's not perfect. First of all, the plane is not a plane. it doesn't fly like a plane. But who cares really? It's about the logic. It's not about the plane flying like a plane. So we're just a normal plane. Why are you rolling so much? Okay, activate that. No, out of the way. Okay. Anyways, as I was saying, it's a normal plane. Okay, this is kind of hard to reset the turn radius. Just a normal plane. Just a normal plane. Okay, pretend there's a target somewhere over there. Look, there's a target here. Yeah, okay, let's loiter here. We're turning the wrong way. The target on our left. Perfect. Let's slow down that. Tiny bit more. Perfect. Now, activate minigun mode. Fire! If there was something there, it would probably lock on or something. Aha! Take that, imaginary target. They're not enough. Let's grab the big cannon. Fire! Fire! Aha! Take that, Stadium. You are my mortal enemy. Get destroyed, Stadium. Okay, so it works. And I really love doing this. So, if you guys enjoyed the video, then I can't name that sideways. If you guys enjoyed the video, then, yeah, like the video. The logic video. We love logic. We love making logic. And it actually worked. To a decent enough degree. I do wish I would be able to make it do the whole thing where the plane's actually turning instead of yawing like that, but that's a bit complicated with the gyroscope just not behaving. I'm pretty happy with how this turned out. The memory thing I had in mind actually worked really, really well, so I'm really surprised with that, because I was thinking of doing stuff with the accumulator, setting up values in that, but this actually worked perfectly, so yay. Anyways, I hope you guys enjoyed. That was pretty cool. We built in like an AC-130 style gunship, and it automatically does curvilinear stuff. I can set up a radius, and it's going to turn around the radius with whatever current speed it's going at. And it works. Just works. So, really happy with it. Tell me if any... Let me know if you have any other logic-based ideas I should try out. This was pretty fun to make. I love the cannon. The auto-aiming cannon too. So yeah, just let me know if you have any other logic-based ideas. But with that, I'll see you in the next video. Goodbye. Okay, I can't. No. No, why are you not getting? Okay, I can't hit this. There we go. Kaboom. Goodbye.